Today we are going to talk about the MDR-TV module, right? And all about its. This is the old one. Yes. All about the module we've developed for the Sajik program. A bit of history about this module first of all. This underwent, as maybe I explained earlier too, there have been three major revisions of this whole MDR-TV program, three overhaulings you can say. The first version was created by Ali Habib from IRD back then, which later became IHS. He was the lead and CEO. So he wrote the first module for Tajikistan. It was quite bespoke and more like then and there kind of work. So he visited Dushanbe actually and wrote the first version there, as far as I remember, and he did that in maybe 2 or 3 days, which was a big feat back then, without ChatGPT or anything, and in fact without even strong bandwidth. So he had carried some documentation, some tools with him, pre-installed, sort of things like that. But that was the first version of this module, and it was built based on an existing MDR-TV module. It was modified heavily for Tajikistan, and that all the new business rules, all the reports and forms were modified accordingly. So the first version had more or less everything hard coded. Most of the rules were hard coded, even the locations, location IDs, concept codes. A lot was just simply plain hard coded, and it was working, but of course not modifiable easily. Then in 2013 or 2014, there were a few revisions, but this was the second complete wave where this model was further enhanced. So some part of it was made dynamic. A bunch of hard-coded rules were switched to OpenMRS style and all, but still a big chunk of the code was still hard-coded, and the biggest thing was the module used OpenMRS's own legacy JSP. So Java Servlet Pages, the mode was as I'll show as well, that part of the code still resides in the module. So we weren't using the REST API at all back then. It was legacy controllers, hardwired with the JSP pages, and we had JSP with Groovy scripts to support a bunch of HTML and bespoke styling, all of that. And this module was populated on the OpenMRS's own interface as the convention goes, right? So this went on for a good decade, and then in 2023 another overhauling came, but this time it was a version upgrade. This was the first major switch, because until then this module was compatible with legacy OpenMRS 1.6, and from that point onwards it took a whole year to move it to its current state, which we are going to see right now. The most important change was moving the UI, switching the UI from within the OpenMRS to a dedicated separate web application, and that web app was built on Django framework of Python. So Python, we use Django. There is although there was no you can say it wasn't compulsory to use Django. You could have used Flask or Fast API. That would have worked as well, but we went with Django because out of the box it's a complete framework. So for example, Fast API is just going to provide you support to build an API and a UI around it, but Django is like a complete framework for that. So we went with Django. Although there is no data repository for the application, there is one database, not database actually, Redis instance, which is being used for caching things, but the main storage is still OpenMRS. So the Django application, when it's deployed and launched, it fetches some of the metadata and coordinates continuously with the OpenMRS. Now, however, this time we are talking with the OpenMRS through the REST API, and that's the most important aspect. That's the most important part to note, because everything we do in the module eventually has to land on the API endpoint, because otherwise it won't be callable. We won't be able to utilize anything if it's not exposed on the via the REST API endpoints. So fast forward again, 3 years later today, we are once again working on it on some pending issues. Now those pending issues involve all the tickets that are there on the Jira instance. The tasks have already been created. There are some bug fixes, there are some changes. The module itself is does not need to go through to undergo a big change, right? However, in order to make it work, first of all, the OpenMRS version which we left last was 2.4, and version 2.4 is again ready to be phased out. It's not going to be supported for long. So I decided to jump the version again to the most recent version, which is OpenMRS 2.8. So this module was then being made compatible with OpenMRS version 2.8. This took some effort because the libraries, the dependencies, most of them were phased out by OpenMRS. So some part of the code had to be replaced, but it eventually started working. I had deployed it successfully and tested on my machine as well as the test instance. Test server is that's not the one we use for trainings. The training instance is supposed to be the live server. So there's another test server where this is working, and the idea this time is whatever work that's pending, we will do that, but also refactor the existing code wherever possible, because plenty of the current module is still contains the artifacts from the previous revisions. So you will see GSP files. I'll explain what these files are, what they did, and their respective controllers. Those are no longer required. So that part, if we can refactor the code, the module code is going to get simplified a lot, and that is also one of the purposes, one of the objectives in this wave. Now let's move on and talk about before we explore the MDR-TB module itself. Let's first see what module development is, OpenMRS module development. So today we are going to talk about the OpenMRS module development. How does OpenMRS module look like, and what packages are used in a module, how do they work. Then we will talk about how to build a module, how to deploy it, right. Also we'll discuss a bit of Docker, and then we'll talk about testing, how to test a module. So we'll see unit testing and test coverage, and then finally, after we've made a bunch of changes, we will deploy the module. So the final half is we are going to fix up, we are going to practically change the module, accomplish two different tasks, and deploy them. So one is bug fix. The first one, we are going to fix a bug, and then the second one, we will make an enhancement, add an addition. The both require, the first one requires thorough understanding of how the module works, how to debug it. The second one is how to modify it, what parts get changed if you add in just one more field to the module. So that's what we are going to look into. Okay, let's dive into the module development. Now, OpenMRS from day one is on pluggable architecture. So pluggable architecture means it uses Spring's power to there's a design pattern called abstract factory pattern. OpenMRS follows that pattern, implements that pattern in Java, and what this does is, during the runtime, it allows you to deploy or add your custom code without recompiling the code, your whole build. In a running system, you can add another class and allow the system to scan for that class and call certain methods within that class. And that's the reflection. This whole thing is called reflection programming. OpenMRS uses reflection programming as well as aspect-oriented programming to enable this pluggable architecture. And this has been one of the key reasons OpenMRS has not and cannot actually move away from Java. There have been talks about how I was in a conference in 2019, I think, and this was the discussion among the prime OpenMRS developers. What can we do to switch away from Java, since you don't see many Java developers now. People prefer learning JavaScript and Python because they're easy. So not because Java is weak or anything. Java is actually very powerful, very strong language, but it's quite easy to program in Python and other languages than it is in Java. But then eventually the talk ended on the same point. If we are going to switch away, what happens with the pluggable architecture we have? The ability to add modules during the runtime, and without restarting, without rebuilding code, they would just simply work. And that was something there was no answer to. Maybe now I'm not so sure what the plans are, but so far I know that the OpenMRS is sticking with Java language, Java as the primary language. However, the UI and other parts of the presentation layer, that has rapidly been changing, and for the past say 8 or 9 years, it's all moved from JSP to pretty much all JavaScript now. So O3 is all JavaScript, single page application. The whole presentation layer does not use Java at all. but we are going to talk about the core, the heart of it, which is module development, which is going to serve the resources that is still in Java. So we will talk about module development. First of all, we discussed yesterday thoroughly in terms of the OpenMRS model and how it uses concepts, how it uses attributable design pattern to allow us to make changes without altering the database schema itself. So again, our modules, it's very rare to add more tables now to OpenMRS, to the main schema, because the main schema provides you enough capability to build around it without altering without even adding another column to it. However, there are instances where you do need to create new tables, add new columns, and we are going to look into that as well. We won't skip that part about adding your own tables, adding your own fields, changing the schema. That is going to be the part of the conversation today as well. Now, OpenMRS, the core OpenMRS is basically, you can say, like a operating system kernel. It does primary functionality, but everything else is a module, right? So the UI now is a module. If you want to migrate data, that's a module. If you want to generate reports, that's a module. If you want to clean data, that's a module. If you want to support custom hierarchy for locations, that's a module. For patient summaries, there's a module. For patient identifiers, there's a module. There's an entire module library of OpenMRS. If you actually, I'll go ahead and show you. These are called add-ons. Yeah, if you navigate to addons.openmrs.org, you will see a whole array, an entire library of modules. These are just you can see the very few mentions. Let me go to top modules. Okay, these are about 20 modules, but even this list isn't complete. Let me just go ahead and search for certain module. Let's go ahead and HTML formatry. Where's the page with all of them? These are for reference application. Hang on. Okay, now so that page I think was removed. If you want to search for certain module, you have to search for it. Let's go to report compatibility. Yeah, so report compatibility is an extension of reporting module. This is where you can download all the modules, and there are literally now I can say nearly 100 modules in OpenMRS library. That's the kind of support and community structure OpenMRS has. You can go to JFrog, OpenMRS's own JFrog, to explore the artifacts if you want to download anything, because OpenMRS has moved to JFrog as their primary artifactory, and over here you will see all the list of entire module, uh, the list of all modules in OpenMRS. OpenMRS jfrog.io. Artifacts, and here we have OMOD, calculation module, logic module, address hierarchy module, atlas module, BERT reports, common lab test. See all of these modules, and there have been many modules which were phased out, which no longer exist, and some of these are really old too, not supported, but pretty much all major modules, the all core modules are supported by OpenMRS's community. So there are custom modules and then there are community modules. So common lab module is a community module, meaning we cannot just make any change to it and publish it on OpenMRS. It has to go through a certain review. But this OpenMRS module we are going to talk about is a custom module. It's not a community module. It resides in the official repository, but we have a different separate branch for Tajikistan only, which is no longer backwards compatible with the original module. So we'll talk about that. But bottom line, a module is literally a Java project packaged as .omod file. OMOD stands for OpenMRS module. Now there are 4 ways to extend OpenMRS's functionality. The first one does not involve any code, very minimum, and the last one, which involves plenty of code, that's going to be our work today, right? So OpenMRS, yesterday we see you can do a lot from just configurations like HTML form entry. That's not plenty of code. You just have one file, you put it there, it's gonna work, populate a form, and you're good to go. But when you talk about module, you're talking about an entire suite of business logic and your own data models, your own services, your own REST APIs. That's what we are going to talk about today. So our goal today is being able to change the module, test it, build it, and deploy the newer version, and make sure that it works over the REST API, the Postman. That's our goal. By the way, we are not going to cover Java as a language. We will not discuss the Spring framework in too much detail. There will be some part, it's already assumed that Java competency is there. However, there are some parts which require some explanation, like AOP, because otherwise some confusion might arise, and I'll explain why I'm saying so. So now, this Tajikistan system is, as I talked about yesterday as well, is a combination of 3 different projects. The first one is the OpenMRS MDR-DB module. This is Java. It provides REST services, it provides forms and reports, and this is what we are going to be exploring. This REST API is consumed by the Django web app, which we will talk about tomorrow. And then there is an ETL job which migrates the data from old server from old TB registry into the new version. There is a modules directory in OpenMRS which is loaded when you launch any instance, right? We will talk about some of the Tajikistan related forms and reports today as well, and show their UI and all, and deploy a newer version of the module. Okay, at this point I am going to introduce one more concept, which is dot agents. Now what is dot agents? Alright, so I'm going to go ahead and show you something in my workspace. Tajikistan. There's a dot agents directory in the code. Even if you go into module code, I'll show you how to check this out, how to build, how to deploy. We'll come to that. I'll begin everything from scratch, and if I run into problems, then I think good. You will find this dot agents folder, and inside it you'll find this graph.md file. Now what exactly does this file do? See, these 82 lines are going to save your AI agent a lot of trouble. When you're trying to get something done via ChatGPT or Codex or Claude or any other anti-gravity or co-work tool, you will give them a task and the entire code now needs to be scanned, right? That's how it goes. However, when you work with an AI, the first thing you're going to tell it is to read this directory dot agents. This way your agent will learn the whole structure of code, where is any particular resource situated, the file conventions, the properties, the layers, all of it. And it won't have to spend now thousands of extra tokens and time assessing the code. So this is called a knowledge graph. This is so-called a knowledge graph. And whenever you make a change, you will also tell your agent to modify the graph as well. So it's not like, for example, we have this Maven dependency HTML form entry 2.1.0. If you bump it to say 2.1.7, then that version also needs to be reflected here. Same goes with other stuff, right? So yeah, again, these are your REST endpoint points for MDR-DB module, and global properties being used, the message or properties files for translations. That's basically one file helping your agent out. So more on that. Yeah, rule of thumb, every time you make a change in the agents file as well. So this is very important to be able to work effectively with an AI agent at your side. Now let's talk about how a general module works in OpenMRS. When we say a module, we are actually talking about two sub projects. There is an API side and there is an OMOD side. Right? Let me go ahead and launch GitHub and OpenMRS. Tajikistan. There are this one, OpenMRS module MDR-TB. I would like you to go ahead and check out this project. Actually, let me do this on my machine too. I just need to make sure that everything is committed. So we are not missing anything. Committing agents. Because I'm going to flush the entire thing. This was a bug fix I made. Should I commit it or not? It's a good question. Hang on, let me quickly update my repositories and then I'll remove and start everything from the scratch. So this one has 3 bug fixes, so yeah. Okay, I'd like you to repeat the steps I'm performing. I'm going to remove everything from my machine and then begin from scratch. So let's take a backup just in case. And let's removing all the repos and also their respective going to OpenMRS here, and again removing the tops, going into Apache Tomcat, removing OpenMRS from here, removing all the logs, removing Catalina work directory. I'll explain all of this in a bit. So basically what I have is everything removed from my system. Now I won't jump straight to the MDR-TV module, rather I will first talk about Common Lab module, because this will serve as a very good foundation to establish understanding of the OpenMRS module development. I'm going to launch IntelliJ. By the way, there are 3 different IDEs I have personally worked on. Earlier we used to work with Eclipse, then we moved to VS Code, and then finally I adopted IntelliJ, and I have found IntelliJ to be the best IDE for OpenMRS development, overall in Java development. So meanwhile I am cloning the Common Lab module on my Mac. It's a bit more convenient. In my desktop I have I don't have the liberty to simply remove all the previous versions, which I did try, but I have plenty of other projects set up, so it's not convenient for me to simply remove everything from over there, which is why I'm going to try on my Mac. What happens is, if you have an incorrect version of Java, that's one main culprit of most of the problems during OpenMRS development. If you have the wrong JDK, then you will keep encountering these issues. So the problem I was facing was also related to the wrong version of JDK. And I now so I'm switching to Mac because it's then becomes really easy.
I was expected to have Vlad here, but I don't know why he's not connecting. Second day. He's in Russia now, but because he's our software developer,
Oh,
he understands the Python, Django, and all this stuff.
then you should
So
be.
it would be useful for him to know everything and help us with the development or with the issues.
Yeah.
Okay, I installed the JDK. Now I'm copying the Maven to my disk C drive.
Okay, so my default over here is Java. Let's check Um, Java home, all the versions I have. All right. So I need to switch to Java.
Okay, and the next one is Tomcat 9. Sorry. Okay. Protection.
So project structure. I need to use the Java 1.8. Still default.
So I have to install Tomcat also in the C folder
Yes.
in the root.
Yes. You can just simply copy it. Mm, Extract Tomcat into the same.
You mean the folder?
Yeah, so you can download Tom. So there's an installer, Tomcat installer.
Yeah.
Don't go with the installer one. Just download and extract the archive.
Okay, okay, I get it. I downloaded the boss. I thought we have to install something, so I'm just cancel the installation and just copy the Tomcat version to the C folder. Yeah, copying it.
Meanwhile, I'll set up my.
So now I have to add the M2 home to Apache Maven 3.
Yes. Set the M2 directory and also add to the path.
I don't know where is the environment in the new Windows.
Okay. It's easy. Actually, you don't need to do anything. Just go to search and search for environment variables. It will just show you. Edit the. It's in system properties, by the way. You can also write system properties or system configuration or system information. But the best one is if you write environment, it is going to show the same window. Yes, so you need to modify these system variables, not the user variables. Let me try the Maven version and now Java version. My Java is supposed to be a different one. So I'm going to export Java home and this is supposed to be user dip exec Java home version 1.401.10. Strange. Let's try 11. No. If I run Maven from over here, so this is still 1.1. Let's try again. All right. Out this module, you will see that the POM file is sort of broken, as in and let me just fix this and commit to OpenMRS because it's really important. .2 and then again 1.2 should work. Even clean install. Force it. Don't find artifact. 1.1.0 snapshot should be .2.0. Let's first let it build, and then I'll explain the change I made exactly. So anyway, this is a Java version issue, not the not exactly the module's problem. What was happening in this module earlier was in the POM file, where the repositories, the links were defined. They were with the HTTP without the encryption, and this was no longer supported by Maven. So I had to change these to HTTPS, and also the JFrog artifactory, which the OpenMRS later migrated to from Maven Central. I added that artifactory to the list of repositories to search the artifacts from, and now now it's building, it's working. The only thing now, you see that it was not compiled. That is because of the Java. We have to make sure that it is using Java 8. So I'll see in the project structure if I could explicitly tell the project to use Java version 8 compatibility, and the same will be defined in settings, importing Java 1.8, runner, Java 1.8, this Java compiler, that's 1. No, we need 1. Java 8, the bytecode. Let it use 1.8 everywhere. Let's run it again. But even if it does not compile, even if it does not build, the objective of showing common lab module is not to deploy this module basically. Yeah, it's the same Java compatibility thing. Let me see if I can force it to use version 6, version 8. Okay, let me ask ChatGPT to take care of this. Even in the Maven compiler I have to do the same. It's good catch. So I have 3.8 Maven. Build plugin formatter. Let's explicitly define Java 8. Remove the version from here. I hope it now works well. Even if it doesn't, this module, building this module in particular is not our main objective. Seems to be doing something. Testing and maybe some test failures. Nothing new. Happens a lot. So I'll simply skip tests. I'll say skip tests. So all these commands, these are essential. Why try to test again? It's beyond me. Anyway, these are all test failures. It will continue to fail all the tests, and yeah, it's basically all the tests that are failing. So I don't know the reason behind the test failures, but that's not our goal right now with this module. We are looking into the common lab module to sort of understand how an OpenMRS module looks like. I'm going to discuss some files in particular to help you guys understand how a module is structured in OpenMRS.